All right, welcome back, everyone. This is now video 2, the complement of credibility. Thank you for your time, and thank you for watching video 1. I do want to give some thumbs up to my 15-year-old son, Andrew, who did help me with the video and with the inset picture and all that. I like to take my picture on and off at different times so you can see that I'm here. Why I say a lot, I noticed I was watching a little bit of the video to make sure that it worked. Nothing quite like watching yourself on video. So hopefully I will talk a little bit slower and I won't ramble as much. So let us do video number 2. Let's talk about the complement of credibility. Another thing I learned is you can see all the slides. You can jump to a certain slide. So let's jump to... Okay, here we go. So what is the complement of credibility? So we spent about an hour so far quantifying the amount that we can believe our data. So that's great. We've done half the job. We haven't done the second half because we now have to select or quantify the related experience that will be used. So we did our z, now we gave what we give our z. We now need to do what we will multiply by 1 minus z. And the quality, and remember I said this last time, the quality of the complement can drive the experience of the original, the estimate of the original experience. So in some ways those numbers are arbitrary, but there's also, I talked about this being before, an art as well as a science. So I think the fact that this is really where the art comes in, is really determining what your quality of your complement is and how much you can drive the original experience. Okay, so what are the desirable qualities of a complement? This is another, of course, I like these for exam questions, so pay special attention. There's two different components. So one is there's mathematical qualities. It has to be accurate, so there has to be a low variance around what I say the future expected losses that are estimated. It also has to be, so it has to be, good. You have to really rely on the number. It has to have a low variance. It has to be pretty reliable. Number 2, it has to be unbiased. So the difference between the complement and observed experience should be 0. The complement theoretically shouldn't really be a function of the estimate itself. It should be completely different. And then that's the third, is statistically independent from the base statistic. So there has to be some level of independence. But also, it has to be practical. You have to be able to get it. So it has to be available. It has to be easy to compute. So there has to be some level of practicalities to it. And there has to be some relationship to the base statistic, which makes it easy to support. So if you're saying, I'm going to use as the complement of credibility for if I'm measuring, say, landscaping contractors, and I'm going to use the loss experience of 24-hour convenience stores as a complement. Now, maybe there is some statistical reason to use it, but try explaining that to somebody. It doesn't make any intuitive sense, so it doesn't really hit the practicalities of it because there's no logical relationship to the base statistic. So there are 6 complements that we are going to go over, some in more depth than others. I noticed the first recording was about an hour. I said I was going to, at least I said to myself, this is going to be no more than 2.5 hours worth of recordings that you're going to have to sit through and watch. So I am going to try to go through these a little bit more quickly than I would have, and some things I'm not going to spend, I'm going to spend very less time on it. And forgive me, I'm going to pause this for a second because I need to make one change. Okay, one thing when you're recording something, you can recognize the fact that you made a mistake and you can stop and change it. So I realized that the third component of the table was not correct. So there's 6 different things. There's a loss cost of a larger group, which includes the group being rated. That's fairly common. You can also use a loss cost of a larger related group. I call it somewhat common, and this is strictly my perspective, how often that I see this used in the industry. Rate change from a larger group applied to present rates. That's not very common. That's kind of weird, actually. There's also something called Harway's method. Some person named Harwain came up with some really fancy way to remove the bias from a larger group. Calculation intensive. The benefit usually doesn't exceed the cost, so that's why it's not common. So poor Mr. Harwain came up with all this so fun method, but we're saying it's not common, so sorry. Then there are 2 that are really common, I think, are trended present rates, and then also using competitor rates. Those are both very common. So we're going to go over all 6. We're going to spend a little bit more time, as you might imagine, on the ones that are common, because I'm a practical person. I'm not typically a super theoretical person. These are called practice classes. So we're going to go over the practical stuff in the practice classes. So let's go through one of the common ones. So the loss costs of a larger group. So I rate group A, so I'm trying to measure okay, I think we're back now. So yeah, we're trying to measure how much can we believe the experience, or what's our complement for the experience for rate group A, class 1. So that is, we have 100 exposures for $50. So we can use, we have several things we can use for credibility. We can use the loss experience from all of rate group A as our complement. So our pure premium here for the latest year is 50 and it's 64. Our complement could be the loss costs of could be 55, which is for the latest year, for doing the latest year pure premium, or if we're doing the pure premium for the 3 years, we could use 57 as a complement. You could use the larger group that includes group A. We can also use the loss cost of a larger group. We can use the whole total. We can use the entire statewide total of 74. So we could weight 50 with 74 could be our complement. That is strictly, that's strictly our choice. And again, this is, you have to, use your experience. So the advantages of this are we're just using a greater volume of data. So we're supplementing our 100 exposures here with something may have 800 exposures, or may have 4,000 total exposures. The data from the larger group is usually easier to compute, and there's also a logical connection. So we're using something else. We're using rate group A. Maybe we're not using class 1. We're using all of the subtotals. Another thing we could theoretically use is we could use class 1 from rate groups B, C, and D. It's up to you as the actuary to determine which one is the best, or which one is the most logical to be used. And the disadvantage is there is some bias to it, because the complement of if you use group A, if you use the entire all of rate group A, you're including the experience. You are biasing it with the experience of class 1. So class 1 is also baked into the complement. So that does make it a little bit less statistically independent, and it depends on what your trade-offs are. There's always a cost, to doing something. And just if you want to just give some examples, maybe on a larger scale, you could use, if you're a multi-state insurer, you could use a total experience of all states, or in a region, or in the total of the United States. You could use all drivers, for example, for an auto insurer to supplement young adults. That may not be good if you think there's a big difference, but that's something that you could use. A commercial insurer could use all the experience of all contractors to supplement the experience of a painting contractor, for example. It depends on what you're measuring and how comfortable you are, but this is really knowing your data and knowing what is a good complement. There's no, again, the thing I like about this, there's no right or wrong answer, and it's really, you have to use your experience, and you have to really know what you're measuring and what your goals are. Okay, so this is the second one. This is a somewhat common. We have this one, just this one slide. This is called the loss costs of a larger related group. So you're not using, for example, you're not going back here. You're picking maybe something else. Maybe you're picking all of group C, for example, which could be related, but it's not. It doesn't include the actual group. So it seems a little less intuitive. I'm going to use all of state C or all of rate group C to supplement rate group A class 1. It doesn't seem to make a whole lot of sense, but in some case it does. So maybe you would use loss experience from owners' forms to supplement condos, so or to supplement what I would say supplement renters insurance. So you use homeowners insurance to supplement renters insurance, or you use bodily injury from all owned vehicles to supplement non-owned bodily injury. Non-owned bodily injury, for example, is if you're like a pizza, you own a pizza shop, and it's your non-owned vehicles, or say that when people use their own vehicles to deliver pizzas. So you're insuring those vehicles. You don't own them, so you can't list them. So maybe use bodily injury from owned vehicles to supplement non-owned. The advantages are it's not dependent on your experience. The data is available. If the groups are related enough, there is a logical relationship. The disadvantages are there is some bias to it. And if you want to correct the bias, it could be really difficult to explain. I don't see this used a whole lot in practice. It's there. It's something else that's at your disposal. Sometimes it's the best that you can do. It really all depends on, on what you have. So maybe you don't have a whole lot of contractors at all. So you're going to use manufacturing or something like that from a commercial insurance perspective. Some of it just depends on what you have and what's available to you. If this is all you got, you may want to use it. Okay, so let's do one that's not very common. It's called a rate change from a larger group applied to present rates. So rather than using the rate change, rather than use the loss cost, you're actually going to use the rate change. So say you're doing you're not doing pure premium analysis, you're doing a loss ratio analysis. So so you would take the loss cost of your subject experience, then you multiply it by the large group indicator loss cost divided by the large group average loss cost. Whatever you think the rate should change. It's unbiased. It's likely to be accurate over long term. The data is available. It's easy to calculate. I'm not going to do the example for the sake of time. I don't want to spend time on things that aren't very common. Okay, this is another one. I was going to do a derivation. I'm not going to subject you to it. It is called Harwain. It's called Harwain's method. I will show you this to you in Blackboard if you want to look at it. It's interesting. It's interesting how Harwain does it. But really, this is, I said before, it's kind of a fancy way of taking a larger group and removing the bias from a larger group. So the advantages, it adjusts for the distributional differences for being unbiased. So it does do a nice job here. If we getting into our previous example of taking out in this if you want to use this the loss cost of the 800 in the subtotal for Class A, it does a nice job of taking out the removing any bias from the 100. I encourage you to take a look at it. I will say it's not going to be on the test at all, but it's kind of neat to see the calculations. But I'm not going to take you through it today. So we'll go through this quickly here. So it's reasonably accurate as long as you can adjust the process variance. Mostly independent. The disadvantages are the computations can be complex. So I have a nice simple example in Excel if you want to take a look at it. the complexity can make it very hard to explain too. Because I said the ability to explain something as a math and as a technical person is enormous. So you need to have the ability to explain something, and obviously having something that's explainable also makes things easy to explain. And I've never thought, especially when you're using thousands and tens of thousands and sometimes millions of records, the computations for Harwing would be incredibly complex. The Excel method the Excel method that I have attached is a really simple example, but you can see how complex it is. So not a big fan of it. Okay, so now we're going to get to two that are very useful, and we are going to spend a fair amount of time on both of these. So the first one is trended present rates. You're not using a larger group. This is the first one you're not really using. You're going to say, I'm taking some different experience. You're going to adjust the rates. These are for indicator rate changes. We're going to adjust the rates as was previously indicated. Then we're going to trend the rates using the premium trend and the loss trend, as we did earlier in the semester. Maybe it was more than 2 weeks ago by the time that you actually read this. So what does this mean that we do? So your complement is the present rate times the loss trend factor divided by your prior indicated loss cost or the loss cost that was implemented, or in the loss ratio method, loss trend factor over premium trend factor. Remember we said before, if the premium trend is more than the loss trends, that means the costs are going down relative to the premium, relative to the way that the exposures are trending. And loss trend greater than premium trend means the exact other way around. So then you multiply by the prior indicated rate change divided by the prior implemented change factor. So you're sort of assuming that your rates are perfect. So it's much easier to show this in Excel than it is to just talk about it. So let's actually talk about this. So here's the Harwing's method. Let me get rid of this thing here for you. Whoops, collapsed the ribbon, my bad. Okay, this is Harwing's method. I'm not going to spend time on it, but it's not that much. I would go through it, but we are mostly going to look at trended present rates. Okay, so we have three examples. We're going to go through each example separately. So our to future loss trend, we're saying loss costs are going down on average by 3% a year. That was our selected to future loss trend. We also selected our to future premium trend of -2. So you have your trend years. This is the trend period, or the number of years of rate change will be, the number of years of rates will be in effect from the present time. This is kind of your to future number of trend years. So now I say my prior indicated factor was +6. So the last rate review I did, I had indicated change of +6, and I also implemented a +6. Remember, we don't always implement what we take, but for the simplifying example, we're going to say indicated change was 6, implemented change was 6. So we have said before, our total trend is, our total trend is 1 plus our loss trend over 1 plus our premium trend. So losses are going down by 3, our exposure distribution is going down by 2. So maybe we're getting more people that qualify for a multi-policy disc, or getting more multi-policy risks, or maybe we're getting fewer younger drivers and more older drivers relative to younger drivers. So our total trend is 0.99. So it's a 1 plus 1 minus 2% divided by 1 minus 3%. I'm sorry, I said that. 1 minus 3 divided by 1 minus 2 plus 0.99. So our to future trend is, all we're doing here is we are trending at 2 years. So this is the number of years our rates will be in effect. I'm going to add that here. Number So now I'm introducing a concept called residual indication. That's really just the prior implemented change over the prior indicated change. So this is again saying, where was our starting point for our rates? Well, our starting point for our rates, we said beginning that we're perfectly priced. So we're assuming that we were perfectly priced last time of 1, and that our to future factor, all that we're going to do is our rates are going to go down by 1% a year essentially, so to 0.98. So our complement is going to be, we're just going to weight in a minus 2%. So we'll take our indicated change and we'll weight our complement of minus 2. Does everybody understand that? It doesn't matter because you can't talk to me anyway. So that's that in a nutshell. Let's go over another example. Sometimes easier when the rates are going up. Okay, so let's do example 2. This time we're saying losses are going up 5%. So we'll say in homeowners insurance, severity is going through the roof, and that's actually I just talked to some of we had there was a trend meeting where we talked about trend meetings. I'm on the commercial. I'm work more with commercial lines, but I was talking with my friends in personal lines today. They said they had a trend meeting and they are seeing losses with inflation and supply chain and now gas prices going through the roof. They're saying, I think auto severity is up like 10 or more percent now. The industry is really seeing a lot of large trends in price of materials, in price of vehicle. I know it's harder to get a new vehicle now. If any of you or your families have tried to buy a car recently, everything is going now with gas prices going up with the Ukraine situation. Everything's really going through the roof. So that's a little aside to say. It's up to the actuaries to determine what's that going to look like in the next year or two. Is this going to continue? You really have to know the industry and really know the world in a way. So it makes things. Sometimes these aren't ideal. It does make the profession very interesting, though. Again, I like to make sure that I talk about that. Okay, so loss trends are 5%. Our premium trends are going up 1.5%. Maybe home, the what we're seeing and just in the increase in housing values is going up maybe 1.5%. We're not getting as much premium for our losses, and we'll use a 2.3 number of years the rates are in effect. So this time our prior indicated factor was 12, and our trend we only took a 4%. So we knew going in that our rates were pretty inadequate. In some ways, 8%, 8% inadequate. And that's essentially, I'm going to jump over here for a residual indication of 1 plus 12% divided by 1 plus 4% or 1.077. So our total trend of 5 and 1.5 is a trend of 1.034. Oops. And our what am I doing? So then 1.034 to the 2.3 power is 1.07. What am I doing? Oh, not squared. Sorry about that. 1.081. My apologies. Is 1.081. I think I had 2 there before when I was working on that. 1. So then we're our trend of future. So we're saying in 2.3 years our prices are going to be 8.1%. Our loss are going to be 8.1% higher relative to premium. So if we did nothing, our price would be 8.1% higher, but our starting point was already 7.7% inadequate. So that's going to drive a complement of 16.4%, or 1.081 times 1.077. So our complement here is very high. So we're saying, if we don't think we have enough experience for our indication, we think that we were priced, we were underpriced to begin with, and our prices are not catching up to our premiums. So we're saying, all else equal, if we had no other data to base our estimate on, we would use 16.4%, and our current experience would make that go higher or lower. And then the final one here. So our to future loss trend is 1.5. Our premium is 3.0. So we're getting premiums faster. Premiums are appreciating, or to current premiums are appreciating faster than our losses. Our rates are going to be in effect only for 1.7 years. I'm going to cheat here and do that. Oh, that was fine already. And our rates are going to be in effect for 1.7 years. So our total trend of 1.5 and 3, our total trend is now 0.985 because our costs are going up slower than our premiums, or our premiums are going up faster than our costs. Our prior indicated factor was -3, but we took a 0. So we're saying our rates are actually redundant. We are actually saying our rates, we're overall a little bit underpriced because our indicated factor was 3, but for whatever reason, we decided not to change our rates, at least from an overall standpoint. So our residual indication then is 0.97. So 3%, our residual indication, our rates were redundant, and we think that our costs are actually going down, even our premiums are going up faster than our costs. So our complement here is minus 5.4%. So hopefully everybody saw what we did here. So this would be our complement to whatever our indicated change actually was. Okay, so what are the advantages and disadvantages of this method? So the data is always readily available because you know what your indications are, you know what your trends are. You're really using the same data for indications. It's fairly easy calculations, and it's also explainable too. So it's easy to explain the fact that, hey, I believe I was either underpriced or get the ribbon back here. So I can say that, I can say whether or not I can say, hey, I was underpriced or overpriced. I can tell the determination I can tell where I was. I can tell what my total trend is. So I know, okay, I know how are my to current premiums changing differently from my costs? How's my distribution of business that I'm getting different from my loss costs? And then I know how long my rates are going to be in effect. So I can just take those and extrapolate those out over a period of time. Then I can just multiply them together. So that is very easy to explain, is very relatable. Hopefully I was able to explain that easily enough to you. That's one reason that I like to talk about this method a lot. Here's the bad part. There's a bias, definitely a bias, because if the past indication, if the past indication, you would use the same data typically. So if you're using 5 years of experience, you may take off a year or two and add another year or two of more recent experience. But, and then, so sometimes you could be just proliferating the same problem. If your other indication was problematic or based on different assumptions or based on the same assumptions, there could be some bias in it. So that's how it's bad in a way, but I think there's a lot more ways that it's good versus how it's bad. So I like this a lot, and this is something I know I've seen a lot of companies use, is the trend, a version of the trend and present rate. Sometimes you maybe trend your loss ratio or trend your permissible loss ratio. There's other ways to do it, applying the rates to a loss ratio, but I'm using trend and present rates for relatability for the purpose of this course. Okay, the other one, we're going to spend quite a bit of time on this one, and that is a complement of credibility using competitor rates. So the competitive credibility using competitor rates, it's good for newer companies, obviously, if you have nothing to base your rates on. If you're going into, say, a brand new territory, a brand new class, a brand new state even, you would want to use competitor rates completely because you have no experience. It's also good if you have a low volume of data. It's good if or if you have a low volume of data in a territory or in a class, and that's what we're going to go over in a little bit. This is another one that is very common. The last two, the three common ones are the common ones I've seen in most analyses. The ones listed as common. The ones that are listed, trend and present rates, common to credibility, and loss costs of a larger related group. The other three, a lot more rare. So the ones that I would say would be on a test are the ones that are much more common. So this is also a way that I'm going to show you about doing class rate making and doing credibility and complements of credibility. So oftentimes, even for larger companies, when you get into class rate making or territorial rate making, you may not have a whole ton of data on which to base your rates when you start chopping data out very finely. So in some ways, companies use this a lot. I use this example. So this is almost a guarantee to be in some form on the exam. So we're going to go over this Excel competitor in, I would say, a fair amount of detail. So this is really I'll show you through this example how we are using competitor factors. So some of this might look familiar from before. So we did this, the whole class ranking with the loss ratio, indicated change number of claims. I'll go over the headings first. We'll skip the 6s and the 7s and then 10s. But then we did our indicated change. Then we did our selected relativity at our base class and our relativity change, and then the off balance. You might remember that. And you might remember before where we had the issue where the loss ratios were kind of all over the place. Oops, he's in here. There we go. So we're going to use the same analysis that we did in our class rate making week. And we are going to now do the same thing with class rate making, but we will apply a credibility factor to this as well. So hopefully this will ring a bell because this class rate making, this kind of example on some form will be on the exam. So be ready for it. Loss ratio, losses divided by premium, right? No problem. So you take your report to your premium current rate level, loss, and apply a loss ratio to it. So you'll just do the loss ratio and the total. I'm going to go through this one somewhat quickly. I guess you also have the example of fast forwarding if you want to do this on your own and you believe that you're correct. So remember, the loss ratios range from 71% all the way up through 82%. And then your indicated change. So that's 3, your loss ratio divided by the total loss ratio. This is your indicated change using loss experience only. So 7877 divided by 7702. We're going to do the -1 because I think it's easier to just see and to make it more relatable. And I screwed up. I did not freeze the row. So let's do that again. All right. So our indicated change is, again, if we did nothing else, we only base it on this, we'd have an indicated change of -7 or +7 to basically -7. But now we're saying, well, these territories are a little bit different size, right? And there's a whole different amount of claims for this also. There's a whole lot of different claims by territory. This one here with the big indicated change has only 124 claims. Do we really believe these all equally? And the answer is absolutely not. So we are going to introduce credibility. What do we need for credibility? This doesn't look like an n equals n plus k situation. We don't know what our process variance or variance of hypothetical means is. So sorry, Mr. Bielman, but we are using classical credibility. I put all the credibility stuff down below just to isolate it. So our credibility is 6. And that, oh, I'm sorry, that's right, credibility, the other stuff is there. Credibility is 5, is your number of claims divided by the credibility standard to the square root. That's a square root system, and limited to 1. So we'll do, I like to do the standard first, and then I'll do the 1. So number of claims, which is 5, divided by the number of claims needed for full credibility, and that is, I'll freeze the row 2. 663 is what we used, so that was, I think, the 90, I think it was a 95 and 5 with 663. And then take the square root. So I just say SQRT. I don't like the carets because that. And again, that gives us a credibility of over 1, and so we'll need to use either the smaller amount of 1 or the full credibility standard. There we go. So 826 is fully credible because our standard is 663. 550 tells us our data is 91% credible. This indicated change of 4.87, I can believe 91%. And let's go all the way down. There is no such thing as total. So we have 3 territories, or 3 classes, I'm sorry, that are fully credible. And then we have the one class, remember, with 124 claims is only 43% credible. This other one here with 275 claims is 64% credible. So we believe this 680, we believe this 227 completely. We're going to use it because it's fully credible, so we really don't care about a complement. But this 6.82%, what do we want to use as a complement? Well, we have competitor factors. So we actually went to a competitor, and we were able to use either that comparative rating software or rate filing or some sort of source. And we, from our competitive analysis, we have determined that we know what our competitor factors are. We know our competitor factors. So we have a factor of J is the base, and we want to make sure your base is the same. So I have our current relativity here also. So our current relativity is 1. Our current relativity here is 1. You see 1.09, 1.15, 1.88, and 0.95. 1. So our competitors rate things very close to us, but it's nice to have this. So I consider using the competitor relativity is like using the competitor's own data, right? So the competitors use, or the other companies or the industry, they use their data to come up with those factors. So it does give us some perspective on how they rate it relative to their base, and the same thing for us. So the competitor relativity is 6/8 divided by 1. So the competitor relativity, I'm going to say, is a factor divided by R relativity. Competitor relativity divided by R relativity is 6 divided by 8, right? Yeah, 6 minus 1. So what I like to do here is we're weighting 2 things now. We are weighting our indicated change. That's this. So this is our indicated change if we had all the data in the world. We would just use this, right? And we did this last week. We pretended we had all, our last time. We pretended we had all data in the world. However, if we had nothing but competitors, we would say, well, if we want to strictly match our competitor factors, we would weight. We just would take this down by 5%. We'd say 1.15. Hey, this isn't right. The competitor factors are completely right. We don't believe our experience at all. So we're going to take these down 5%. We would raise this territory here, the lowest price territory. We raise by 5.8%. We bring it up closer to the mean. So the thing I really like about this is you're weighting two different things. If we believed our own experience, boom. If we believe the competitor experience, we would just use the competitor factors. So the nice thing is about this method then is at what you're essentially weighting these two factors. So before you do that, there's a couple of things that we need to do. So first we need to take what I would call the off-balance competitor relativity. And that is 6b. Wait, oh, I'm sorry, my bad. Total 6b is 6 weighted by 1. So first of all, we need to recognize the fact that these may not weight perfectly. These may not be perfectly factors of 1. Remember the off balances we talked about before. So sum product weight by 1 divided by the total. So 1.35. So if we did this, if we use our competitor factors, we would have a change of 1.35%. If we use our own data, our indicated change would go to 0. So we need to make sure that these are in perfect balance. Right now they're not. Right now they're weighted a little bit more toward an increase. So that's your off-balance factor is now 1 plus 6b divided by 1 plus total 6b minus 1. So that's just using percentages and putting them into factors of 0 to 1. So what I say, 1 plus 6b divided by 1 plus the total 6b minus 1. So that should go to, minus 1.33. We're just, all we're doing is we are taking this method and we are, we're weighting it to 1. So obviously now we can actually weight these factors. So these factors are off balance ones. So we're kind of getting rid of those, and we are weighting by we're weighting by these factors. So in some ways you could do it could be kind of funny and just kind of strike these guys out. So we don't care about these anymore because they're a little bit off balance. So we just did a little correction. So I hope you understand this. I really recognize why I like being in front of people now, because I can see whether you're getting it or not. The last class got this pretty well, so hopefully this isn't too bad. There'll be a couple homework problems on it too. Okay, so your credibility weighted indicated change. Credibility weighted indicated change is basically 4 times 6, so your indicated change times a credibility. So your indicated change times a credibility, plus your off balance, or plus your comparative to your competitors times a complement of credibility. So for class J, we're just going to strictly use our experience, because 2.27 times 1 plus, doesn't matter what this number is, times 0. So we can use our entire experience for this. For the 6.82, we're saying, well, we'll use our 6.82% 43% of the way, but the other way says the competitor is saying take the rates down. So there's sort of like a battle in a way. So we're going to, so we'll weight those accordingly. So 4 times 6, so this times, sorry about that, equals this times credibility, plus, you don't need to have parentheses because of the law of order, plus your off balance times 1 minus the credibility factor. Some people like to use the parentheses. I'm kind of one of them. I don't know why. It looks easier to someone who's trying to change it. This is just being considerate to someone who might change your spreadsheet later on. So your credibility weight indicated change is 2.27, because that was your indicated change. The credible one that was 43% credible you weighted 6.82 minus 4.87, so you really get no change. So there is a little, no, so even though this is maybe a little bit less profitable here, you're saying we really can't, the competitors are saying, this competitors' data is saying maybe we're a little bit lucky. We're a little bit unlucky, I should say, with the 6.82%. This one's getting a 7.43%. We're saying, yeah, this is truly good, even though the competitors are rating this higher, or even though I should say, even though the competitors we are saying what's competitor factor minus 5.43 or 5.43. Yeah, the competitors are saying we should we're 3.5. My bad. I wish I could delete that. We're 3.5. The competitors are 3.7. So the competitors are saying take it up higher, but we're having really good experience here. So theoretically, that also means that we could be, maybe that's a good competitive advantage for us too. So this analysis can also show where we might have some competitive advantages. So we think our rates are going to be a lot less. It's already less than the industry, and we're super profitable here. So we could take the rates down even more. We would, in this case, I would tell our salespeople and stuff to say, hey, whatever we're doing in Class N, we're doing a good job writing it, and write more of it, because we can really, we can write this profitably and competitively. So your conversion rate typically would be higher. Okay, so now your credibility weighted indicator relativity is just saying what? 1 plus 7 times 8. So yeah, 1. So 8 is your current relativity. So it's basically 1 plus your indicated change. Oops, didn't do the equal. Sorry about that. Equals 1 plus 7 times 8. There you go. 1.023. So our indicated relativity for this one example is 3.69 and 3.24 versus the competitors. Row 10 is 9 divided by base 9, so that is your, you do need to have a base class, if you will. So our base is the one with a factor of 1, so this divided by the base class. Divide it all down. Okay, so then you want 11 is pretty much what you would like to do. So your selected relativity by your base class. So this is just where really just where you choose 1.17. I'll just round these. 1.91, 1.31, 3. This was the one. So maybe I want to make this 3.2. Maybe I'm a little uncomfortable going all the way from 3.5 all the way down. As an actuary, I think you want it to be actually probably 3. I'll do the actuarial method before. And this is 0.85. Your relativity change. Forgive me 1 second. All right, we're back. Okay, sorry, I got a phone call. All right. So our relativity change, or row 12 is 11 divided by 8. So the actual relativity change is then this is your selected, I should call this the selected relativity change. Minus 1. Did not subtract 1. So this is your real relativity change. So you have 0. You see have a lot of decreases in there. That's because we took the relativity down at the base class. So you will have to offset this with your base rates. So I think 12 total. Sorry about this, getting a little. Oh, let's get rid of this first. There you go. So total 12 is again 12 weighted by 1. sorry about that, divided by 12. Now you divide it by, we'll cheat and do B12. That's your total, that guy right there. So minus 2.4. So if you did nothing there, so you'll need to take a 2.4%. You'll need to take your base rates in order to offset that. So this is going to give you a minus 2.4%. So you'd have to take your base rates back up by 2.4%, or whatever the reciprocal is, in order to actually make this a net zero change, primarily because you took because you sort of artificially took everything down 2.3%. So your actual percent change for the class 13 is more instructive. Your actual percent change with your off balance is 1 plus 12 divided by 1 plus total 12. So it's just really essentially what is the real change that you're taking. So whoops, equals 1 plus 12 divided by, oops, sorry about this. It's 1, oops, 1 plus total 12 minus 1. You're basically just backing out. You're just backing out the change. This is more for, this is your base rate offset. And this is your, whoops, oh, I didn't do this. So much fun watching someone type. Yeah, that makes more sense. That's your actual change. With your off balance, with your offset, with your base rate off balance. Okay, I hope that this is important. This is really a full class analysis here. For the exam, I'll probably give you part of this or a piece of it. Whether you'll have to do, or maybe, I'll give you the headings and things like that. But you will need to understand how to calculate this, and kind of really, mainly why it's so important. Another neat thing to do, I really like to do a lot, is, so we say, okay, this is a huge change, taking this one down 7%. We're already competitive on it. We don't think we need to take, this is some price optimization. We don't need to take this down as much. So our current relativity is 3.5. What if we just took this to 3.3? If we made this 3.3, notice now how everything else went down. So we sort of took money away from class N here, and all the other classes benefit. I'm just going to do another Control Z and a undo and redo. So I removed my adjustment. Now I sort of added my adjustment. So by doing that, we kind of tightened up everything else. So we tightened up all the other changes. So that's really where you would have to offset less in your base rates. That's really all that does. So that's one thing I really like about that, is it shows how you can also select to make those changes. So, any questions? If there are, email me. Okay, if we were truly in class here, I would go over another example. I would go over this second competitor 2 example. I am going to give this one to you, one with blank and one with answers. And I guess if you want to look at this again, you can go back and look at what I did. It's essentially the exact same calculation. And I will, for the sake of this video, I'm not going to do it. And then look at the answers. Or actually, you know what? All right, I'm not going to edit this, but I changed my mind. I'm going to go through the rest of the PowerPoint, and then I'm going to go do this. If you feel comfortable with it, you can just stop the video. So we're already at like 55 minutes for this one video, but I'm going to go back and talk about the advantages and disadvantages and wrap up complement of credibility. But if you want to do this, if you want to look at this again, see another example, I will. I'll go through this example with you. If you don't, you want to do this on your own, just stop the video and do it on your own. So then maybe that's one nice thing for video is you have a little bit more options. But the first things first, I'm going to do the complement of what is the advantages, disadvantages for competitor rates. We've already gone over this. So the calculations their calculations are pretty straightforward. There's a logical relationship, and I've heard regulators say this is almost their favorite way of incorporating competitor rates and credibility. I've had some regulators actually go out of their way to praise this methodology. So this is a good methodology. There's a lot of logical relationships. It is how does the industry price it? And then I really like you're using the competitor's own data. And it's not, this is more, you're not trying to compete. You're not trying to do a price war or anything like that. It's really just saying, okay, hey, so-and-so, State Farm or Geico or Allstate or wherever you're competing with, who does a good job of rating it? And may not be your competitors. Like some agents have told us, well, State Farm's not our competition. The competition is like other independent agency companies say, like a Travelers or a Hartford or maybe the Geicos of the world. State Farm people, we don't get State Farm customers because they don't leave very much because they're usually pretty happy. So, so it should be the competitor, not necessarily the company that you're competing with, but the company you think does a better job of pricing. Or you can use a multiple competitor rates too. The disadvantages. I said the competitors are essentially using their own data, but what if the competitor has different ways of rating? So maybe the competitors are saying, like I just did with that, last, this last example here. I sort of took the 3.3 and I said, we don't have to go all the way down to 3.17. We can just go down to 3.3 and be happy because we're using judgment. Well, competitors could be doing the same thing. Their rates may reflect judgment. Maybe their rates reflect something that's not sustainable. We don't know that, but we're sort of using the competitor rates and not thinking that they did it. There might be different underwriting and claims practices for competitors. They could adjust claims differently from the way we do. They might underwrite differently than we do. Maybe they underwrite young drivers very carefully, and we accept whatever young drivers we want. That would reflect in our data and be a difference between our data and our competitors' data. And then they also maybe competitor rates could be hard to get. There's way, and you have to make sure the class methodology is consistent or the territorial methodology is consistent, and that's not always good to do either. So they could be difficult. These competitor numbers that we've got here. This 1.0 and 3.69, there could be some manipulation that needs to be done. So it might be difficult to obtain. It might be difficult to calculate. And so that is it for complement of credibility. If you don't want to see the example 2 or competitor 2 here, feel free to stop if you haven't already. If not, continue on. So I'm going to turn my picture off here for a second. And we're going to go over one more example. Okay, this is the same example and essentially the same calculation. I'm going to go through the ones that we're used to a little bit more quickly, and then I'll go through the rest a little bit more slowly. So we all know at this point in our course how to calculate a loss ratio. So loss ratio of 63%. These are, again, premiums and losses, sort of arbitrary numbers on my part. And then the indicated change is simply the loss ratio divided by the total loss ratio, 0.63 over 0.599, and so on and so forth. Wide range of changes here. Minus 13%, this has a 52% loss ratio over about 60%, or 11.82%, 67 divided by 59.9. a wide variation in number of claims. So our standard again is 663. 663, our full credibility standard. 300 claims, 120 claims. We only have one territory that looks fully credible. So what are our credibility calculations? Our credibility calculations, again, are number of claims divided by our full credibility standard, the square root. And then, of course, with the we max it out at 1. I've always thought it's funny if you do a max with a min function and you do a min with a max function. I always have to, still, after all the years of using Excel, I still have to think about that. So our lowest credibility here, 30 claims, is still 21% credible. I've still found, you only have 5% of the claims, but you're 21. I've always thought that's still rather interesting, but that's the science of credibility. Okay, so we have our competitor relativities, and we have our area relativities. So our competitor relativity, I'm going to pause this for, I clarified that one heading again. So competitor relativity, 6b is the competitor relativity divided by our relativity. So our relativity is our current relativity here. So 1.6 divided by 1.8. So if we're strictly, minus 1. And what's up with the color? There you go. Okay, so the competitor relativity divided by our relativity, again, is if we did nothing but take the competitor rates and use a relationship, what would we do? First thing you do is you can see there's a whole lot of negatives. So whatever the competitor thinks is a base, we think is a base is our different base. Sometimes the competitor may not have the same base, or they may not work out. So this is one example of using that methodology. So 6c is really, if we want to take a 0, what would our indicated change be? Oops, I did not do our total 6b. I apologize. Actually, I think I have it right here. Yes. Oops. Forget about that. I actually whited these out. So yeah, minus 5.27. So our off-balance competitor relativity is our off-balance competitor relativity, without having to type it in, is you divide 11.1 or minus or 1 plus whatever 0.899 divided by 0.95. So our off balance, we're just shifting everything by 5.27% because I noted before there are a lot of negatives. So we need to make sure, because our loss ratios, all loss ratio relativity all works out to 0. Our off balance competitor relativities need to work out to 0 too. So yeah, these are the things these are the two things that we are weighting. So we're weighting we're rating that column, we're rating column 4, we are weighting column 6b. So I really like to make that distinction and make that delineation. So the credibility weighted indicated change then is, you weight the 5.4, 5.14, and the 6.16, and the complement goes to minus 6.16 for the credibility. So equals, let's do this first one. We're going to get 1.44. Again, we are weighting indicated change with the credibility and the competitor relativity with the complement of the credibility. 1.44. And let's just fill all the way down. Now you can see how these all got a little bit closer together. So this minus 13, we're saying we should weigh with a plus 13, so it just means we're probably unlucky, but we should reflect the fact that we're having some good experience here, so we don't have to go all the way. We don't have to take it all the way up to the competitor because so we have some good experience. Same with this large indicated increase. We don't believe it a whole lot. So we're using, notice we have a large indicated increase. We don't believe it very much. So we're using more of the competitor. But since we do have some poor leading experience, we're not taking it all the way. We're not going all the way to minus 6.16 because we think we can believe our experience a little bit, which is why we're going to 2.34. I hope everybody understands that. I don't know if your heads are nodding. But so our credibility weighted indicated relativity then for 9 is 1 plus 7 times our indicated change. So 1 plus our indicated change, 1 plus our indicated change here, times the current relativity. Whoops, I did not take that all the way down. There you go. 1.826. So you can, kind of filling it all back. Sorry, I'm a big fan of freezing paints too. Okay, that makes it easier. Yes, that's much easier. So our indicated relativity, these are our indicated relativities. Let's go back and redo our base so that you just take your indicated relativity and divide it by your base class. What do I do? Sure. Yeah. Sorry about this. There you go. So we're just knocking it down by 1/1000th of a point there, basically, of a relativity point. So our selected relativity, we'll just select all of our I'm just assuming I like this a little bit different for our selections, just because I do like. I'm going to change this one into red. That's our selected, and I will make all these consistent. And I am a big stickler. You should be too for consistent decimal lineups. Okay, so then and then I think, do I have 11B also? No, I don't. So our actual relativity change then is selected relativity divided by current relativity minus 1. Make it into a percent. I'll just use a percent and increase decimal. So these are our selected relativity. Really didn't change a whole lot when you think about it. Things only went up or down by 1.2 percentage points, which is really nice because that's what credibility does for you. That's one thing I like about it. Notice our indicated changes here. We're all over the place, but we smoothed our data out a lot, which is really what I like about this methodology. So we need our overall relativity change. So sum product of our relativity changes and our written premium divided by our total premium and 0.8. So we need to off balance these without looking at the formula. 1 plus relativity changes divided by 1 plus the base. So we'd have to offset our bases, and what a ugly looking thing that is. I have no idea why Excel for percentages adds like 10 decimal points. It drives me absolutely crazy. And then it increases the column width too. So one way in Excel, so this is a column width of what, 8.09. Nice some consistency in your column widths here. There. So these are your, whoops, and I did this again. So glad you're probably watching this far. I wonder if any of you are watching this far. Okay, there's your actual changes. 0.3, 1.4. So we weighted. We're able to weight our changes in a really consistent basis. So it's really nice the way that it works. So that is it for this for number 2, and for video 2 we'll slide over to video 3.